So you can see the sweet and cute girls of class 9B, and I'm very excited to see their model. They have bring water to swim, right? Okay, all right. Without spending further time, let them start. Right. Very good. Chala.
So, hello everybody, we are Team Jupiter. This is me, Disha Borua, the group leader. This is Kasturi Bora. This is Kushi Sahani, and this is Kumari Kanya Datta. And we four are over here to explain to you guys what is Archimedes' principle, that is buoyancy. So, let us start with our PPT first, a little bit.
Oh, you put some music also.
Let's do it.
Okay, let's do it.
These are the subtopics. Statement of Archimedes' principle, causes of buoyant force, factors affecting buoyant force, volume of fluid displaced, relation between buoyant force and weight of displaced fluid, floating and sinking objects, conditions for floating and sinking, relative density, density and relative density's difference, applications of Archimedes' principle, and lastly, examples based on daily life.
Wow, very good. Detail.
This is what Archimedes' principle states. Mr. Archimedes said that when a body, an object, is immersed fully or partially in a fluid, here we are taking fluid as liquid for a better understanding. Fluid can be either gas or liquid. The object experiences an upward force equal to the weight of the fluid displaced by it. What does it mean? We'll be explaining here. Further, buoyant force, that is the upthrust acting on an object, is equal to the weight of the liquid displaced by that object. Okay. Then what are the causes for buoyant force? Why buoyant force occurs? So buoyant force, here it is written, buoyant force is caused by the pressure difference. Okay, we'll mark here pressure difference in a fluid due to gravity, resulting in an upward force equal to the weight of the displaced fluid. Here we are taking this ship, this boat as an example, that is floating on water due to buoyant force. The pressure difference here on the upper part of the boat is different from the pressure difference, difference here. Okay, this part, and the pressure difference acting upon here by this water is different, because the atmospheric pressure here, if we calculate by further scientific expressions, will be much less than the buoyant force, because of which only this boat is able to float here and move in the water. That is what buoyant force does. That is Archimedes' principle. Now we'll go further into it. This part will be explained by Kasturi. This part will be explained by me. That is factors affecting buoyant force. What are the factors? What are the objectives which helps for the occurrence of buoyant force? That is two things: density and volume. What is density and volume will be explained by Khushi, but now we'll understand how it affects. So density of the liquid. Higher density of liquid produces greater buoyant force. So the more the density of the fluid is, then the density of the fluid makes the buoyant force much more, and then the objects can float much more easily. So here we are taking density of water. The density of water is 1000 kg per meter cube, or we can say 1 gram per meter cube. Then the volume of the object also has a large impact on buoyant force. Greater immersed volume results in greater buoyant force. So if the object's volume is more, like it's very large quantity, then also it affects on how buoyant force occurs on that object. Now we'll continue again. Now the remaining parts will be explained by my co-members.
So my name is Kasturi and my topic is volume of fluid displaced, and there are two more topics. So volume of fluid displaced means the amount of fluid pushed out of the way by an object when it is placed in a fluid, liquid or gas. The amount of space that occupies space is known as the volume of fluid displaced. So, an example, when we drop a stone in a bowl of water, rises or overflows. The amount of water that rises or overflows is known as the volume of water displaced. So, according to Archimedes' principle, the amount of, the buoyant force acting on an object is equal to its weight, um, of an. So next, Archimedes discovering the law of displacement. And my another topic is a relation between buoyant force and weight displaced by fluid. So, wait. Of this weight of fluid displaced means the when the buoyant force is when the buoyant force is equal to when the buoyant sorry the amount of water displaced by the body immersed in a fluid is equal to its weight of the fluid displaced by the body. Conclusion: if the buoyant force is equal to the object's weight, then the object floats, and if the buoyant force is less than the weight, the object sinks. And if the object is greater, the object rises. Another one is floating and sinking of objects. Um, and floating and sinking of objects in a fluid this in a fluid often fluid is um, into condition when the buoyant force is greater and the weight is less. If the object sinks if in a fluid if its density is greater than the density of the fluid. An object floats when the buoyant force is equal to its weight. Thank you. Now rest of the part will continue by Khushi. And continue.
So my topic is condition for sinking. There are two conditions in which an object will float. So it should be equal. Sir. Small mistake. Buoyant force equals to the buoyant force equal to the weight of the object. It means the buoyant force acting on an object is equal to the weight of the liquid this liquid displaced by the submerged part of the object. For example, when a boat is floating, the weight of the boat is equal to the weight of the liquid displaced by the submerged part of the boat. And next is density of the object is less than the density of the liquid. It means if the density of the object is less than the density of the liquid, the object will float in liquid. For example, the density of the wood is less than the density of the water, so it floats in water. And next is conditions for sinking. There are two conditions in which an object will sink. Buoyant force is less than the weight of the object. It means an object will sink in water if its buoyant force buoyant force buoyant force is less than the weight of the object, and density of the object is greater than the density of the liquid. It means if The object will sink in water if the density of liquid.
Very good. Keep on mic. Very good. I like your try, what you did. But actually, this is what not actually I wanted. I wanted you to present by demonstration why model is here. You explain, you're reading like. I'm not here to make you read here. You have to present here, like your live, whatever you are giving the information, I want to demonstrate it in reality, practically. They're saying that how the object sink. You show why, you ask the question that why it is sinking. Okay, now when it is flowing, why it is floating. When you give why it is sinking, question is that na. So put a question, make live, make the topic more live. Put your hand. Now there you are putting hand picture. Okay, let it be. It is for reference only. Okay, here not to just you have to make it more interesting. Show it the real reality. Practically you have to show. This is what actually I wanted. Understand? Make it no problem. You did very well. You tried. You work hard. You bring all this thing. That's very nice. But thing is that little bit live. Like every information should be live and demonstrate through practical.
So the live part is in the last part. First, we are giving the details so that they, while we are explaining, they get a better concept. So the live part will be there, but in the last part. Before that, we are explaining.
Now I am showing that while you explain, why don't you show it? Explain also, show it also. Why the object sing? It is sing because this is that. This is the way you have to represent. You tried well. I want you to do it once again. Okay? Well done. Chalo, take it. Do it once again nicely. Next class we will be doing next day. Okay? Take 2 more days and little bit lacking of confidence is there. I find it. Okay? This one you need to work in out. Okay. Stop. Thank you. All right. Tomorrow not.